So the algorithm that we're going to do for a weighted shortest path algorithm is Dijkstra's. Now, this can be done with a directional or unidirectional graph. This is going to use the breadth first search that we used before, so heads up, but it's got a twist. Remember that when we did breadth first search, if we visited already, we just ignored it. Haha, here's where things change. What if we visit a node that's already been visited, but we have a shorter path? Then we say, wait a minute, node, I got a shorter path. Let's update you to connect with me instead, so your path is now shorter. That's what's going to go behind the scenes. So when we track things, we're doing a tentative distance along with visiting of nodes. So you're going to see the table that I have here. It's going to look somewhat familiar and then somewhat different. So in this overall table, you're going to see that we have our starting vectors, our known, which is kind of like our visited type of thing, our costs and path. So there's a lot of things that are going to be in this structure that I'm going to show you with an example here in a minute. Here's the other thing to keep an eye out for, though, is that this is going to be what you're going to be graded on. This is your work. Think of this as your math problem. So we're going to see changes. I'm going to see slashes. You're going to see me, cross things out and put a new value in there. That's what we should see in this table when you're all said and done, because that's the data that's really being held and continually updated as we're using our Dijkstras in order to determine the shortest path. So background information, we'll watch an example and we'll go from there.